This video is about single linked list data structures along with its operations. Single linked list consists of series of nodes connected to each other. So, as the name suggests, each node will have exactly one link pointing to the next node. This is an example of a single linked list. So, you can see only one link that is being used for connecting the nodes. I have already discussed about the basics of single linked list with the example, so you can check that by using the link provided in the description box. So in the screen you are watching the basic operations that can be performed by using a single linked list. So out of all these operations, in this video, let's discuss about the insertion and deletion in detail. Insertion can be done anywhere in the list depending upon the position of the data where the user wants to place it. Okay, so you can insert the data in the first node or else in some intermediate nodes or else in the last node depending upon user's criteria. So for inserting a data, you're having some 4 steps to be followed. I'll explain you with an example. Consider this singly linked list. Here I just wanted to insert a data in the second position. So for that, first I'm going to create a new node. So while creating a new node, automatically the address of that particular node will be generated. And now check whether the node is empty. Yes, it is empty. So I'll place my data in the new node, which is my third step. And the fourth step is very essential, that is providing the link accordingly. Okay, so since I just wanted to insert in second position, I'm deleting this particular link and I'll assign the link as follows from the new node to the next node. Okay, this is how I need to create the link. For that, the address field are being altered appropriately. You can see that, and the links will be established. Now the same concept I'm going to explain you with the routine. So the first step is to create a new node. So here the new node is being created using malloc function. So the malloc function will allow you to create the memory address dynamically. And the second step is to check whether the new node is null or not. If it is null, then you can insert the data in your new node. And after inserting the data, what is the next step? To provide the link, right? So for providing the link, you are assigning new nodes next is equal to piece next and piece next is equal to new node. This process only we have done over here. Okay. This is how we have to insert a new data in your single linked list. Okay. Now we can see how the deletion operation is being performed. So any data that has been specified can be deleted from the list. It is very easy. For that we have to follow some 5 basic steps. Okay. In this example, I am going to delete 100 from the list. For that, first I am going to find out the previous node of the delete element. So previous node of 100 is the node which is having 10 and I am going to assign it as P. Now check whether the delete element is in the last node. Whether it is in the last node? No, it is not in the last node. So you can assign the next node of P as temp node. So the next node of P will be assigned as temp node. And now assign the link accordingly to delete the temp node. Okay. So for that you have to delete these two links and you have to create the link between 10 and 20. Finally, you can delete the temp node. The same I am going to explain you with the routine. Okay. First, we can assign P to the previous node of our delete element. So we know our delete element over here is 100. So the previous node of 100 is node 10, which is assigned as P. And check whether if it is not in the last node. Yes, it is not in the last node. So now temp is equal to P is next. So 100 is being assigned as temp. Now the link is being changed appropriately and finally you can delete 10. Okay, this is how the deletion is. performed in a singly linked list.